So today we're going to talk about the KMS, which is the AWS Key Management Services. So basically, this is one of the key element for data protection within AWS. So AWS Key Management Service is a managed key service that is used to encrypt, decrypt, and maintain the keys for us. So this is a sort of a built-in managed service that is provided by AWS that simplifies a lot of complex work related to creation and usage and management of the keys. Particularly in a cloud situation where we have a multi-region environment where we need to ensure the data is retained in a particular region. KMS keys plays a crucial role in making sure that the keys are retained in a single region, and as a result, the data is also retained. KMS is very region specific, so you need to keep that in mind when you're architecting the solution. So the keys cannot be exported to other regions. So in terms of the functionality of the KMS itself, let me share the screen. Okay, so the top part, the KMS, is the AWS service that we were talking about. So the primary functionality of the KMS is to create CMKs. So CMK is customer master key. So this is like a wrapper which contains the encryption keys as well as the cryptographic material. But usually the CMK is just a wrapper, and we're going to need further elements to actually encrypt large data. So we'll get into that in a second. But first, CMK is like the master entry of the key. So this is something that we can actually see within our AWS Management Console as well. So this CMK has got a unique ID, and we can create something called alias for easy reference. So if you go into your identity access management within your management console, you can actually see the list of keys listed. And I think now the interface has slightly changed, and KMS has got its own sort of menu now. So if you click on that, you should be able to see the list of keys, and there would be two types of keys that you can normally see. One would start with AWS backslash whatever the service name, for example, S3 or CloudTrail. The other one is the custom created keys. So these are the two type of keys that are available within the KMS. So those are two types of CMKs as well. So alias is nothing but a user-friendly name for these keys. The CMKs would be normally a numerical key, which is difficult to remember. In terms of operation, a KMS initially creates a CMK. Say, for example, if you want to encrypt a file. So this is the end file you want to encrypt. So initially, we create the CMK, and we would create an alias. Then we would create something called as data keys. So data encryption keys called DEKs are the one that is actually used to encrypt the data. So as I mentioned before, CMK is just a wrapper, and it points to the respective DEKs. So the DEKs allows you to create a plain text key and an encrypted key. So the plain text key is, again, both of them are base 64 encoded keys within AWS. So the plain text key is the one which is used to actually encrypt the data. So that's what is encryption. And then this plain text key is deleted. So once the plain text key is deleted, the encrypted key along with the encrypted data is often stored together. When we need to decrypt the data, we then use the encrypted key to create another plain text key. And using the plain text key, we then have the encrypted data gets decrypted. So the plain text key and the encrypted key initially gets generated. you encrypt the data using the plain text key, and then delete the plain text key, then save the encrypted data and the encrypted key together. When it comes to decryption, KMS uses the encrypted key to create a plain text key, which is then used to decrypt the original data. So this is, if you like, the sequence of events that normally flow through. Probably if I may give an example that might make it easier. So as you can imagine, the KMS can be used in variety of AWS services. So S3 is one of them. Say, for example, if you have enabled the SSE, the server-side encryption on the S3, and say an user is saving a file, for example, a confidential file, can you see the same, this one?
It's still showing the paint.
Okay, sorry, I think I moved on to the next without sharing. Can you see this now?
Yes.
Okay, right. So this is basically an example of how encryption works, for example, with S3. So we have a user who has created a confidential file, and he's saving that in an S3 bucket, for example, and he's enabling encryption. So what the S3 would do is it would request KMS saying, I have a encryption request for a particular file, and then the KMS would then creates a CMK first, a customer master key for this request, and then it generates the data encryption key, so DEK, which contains two parts. So the plain text key that we spoke about, the other one is the encrypted version of the key. So it passes both of these keys back to S3. So S3 uses the plain text key to encrypt the file, and then it deletes the plain text key, and then it saves the encrypted file along with the encrypted key. So remember, the KMS sent both keys to S3, right? So it uses the plain text to encrypt, deletes the plain text, saves the encrypted file and the encrypted key. When it comes to decryption, say for example, if the user wants to open the file back again, S3 picks up this file. So it says it's encrypted, it has an encryption key. So it passes the encryption key back to KMS, and KMS has got its own database of the keys, custom master keys, the respective keys and everything. So it uses the plain text key to decrypt the encryption key and then passes the plain text key back again to S3. And S3 uses the plain text again to decrypt the file and passes the file back again. Okay, let me go through this again. User saves the file in S3, enables encryption. So once the encryption is enabled, KMS looks at the file, creates a customer master key and data encryption key, which is the plain text key as well as the encryption key. So it passes both keys back to S3. S3 uses the plain text key to encrypt the file and then discards or deletes the plain text key. So it now has the encrypted version of the file and the encrypted key itself. So that's what it contains. When it comes to decrypting it, when the user accesses it again, S3 looks at this file, it has the encryption file as well as the encryption key. So it passes the encryption key back to KMS. So KMS looks at it, it decrypts the encrypted key and generates a plain text file. And the plain text key gets passed to S3 again. And S3 uses the plain text key to decrypt the encrypted file, which creates the plain text file for the user to read. Any question? Is it slightly confusing or I'm going too fast?
No, it's a good pace. So what happens if, does it regenerate the same plain text, whatever pen is using for encryption? So decryption is the same key or it just generates different key every time?
Okay, so it's a different key because originally when the encryption happened, so the S3 used the plain text key to encrypt, right? That key gets deleted, so that's discarded. It's not there anymore. So that's how we can save this data publicly. Anyone can access it, but they can't encrypt without the plain text key. So we need to come back to the key provider for a plain text key to be generated for them to decrypt.
Okay.
So every time a new plain text key is generated.
Right, thanks.
Yeah, so is it right in saying that KMS is only prevalent in scenarios where we use server-side encryption?
It's an easy example to give, but there are other scenarios as well where you can use. And the advantage of using KMS is we wouldn't even realize all these things happening in the background. It does it all for us.
Okay. But so it's used in other scenarios as well,
Yes,
not just.
yeah. Cloud Trial and so many other services can use. Yeah.
Okay.
What is the, yes? What is the role of customer master key in this whole scenario?
The CMK is, if you like, the master key. It has like how do I call this, like a container. It contains the information related to the plain text key, the encrypted version of the key, and KMS has got something called as a registry. So it maintains its own registry, which has all the information related to all the keys that has been generated. So it knows for which CMK, which encryption key or plain text key is related to. If it like it maintains a master registry of which CMK is one of the entries. And within those entries, there's got a detailed information of how many keys been generated, what are the keys available, and so on.
Okay, fine. Thank you.
So that's in essence what CMK is. So the size of the CMK is very little. So you cannot, in theory, encrypt or decrypt anything more than 4 kilobytes with CMKs. So that is the purpose of creating the data key. So that's the role of the data key, to actually go and encrypt. So the actual encryption happens at the data key level. CMK is more like a reference material. Yeah. So the advantage of KMS is AWS does this end-to-end for us. So all we need to do is enable wherever suitable, and it does the backend integration for us. We can also create our own keys, import them in AWS, manage them similarly, but it's a lot more cumbersome. It is quite manual. Unless and until there is a good reason to do so, for example, compliance, another reason, probably it is advisable to use KMS to start with at least. In terms of KMS, it is a hardware-backed service, and it's FIPS 1402, which is a level 2 certification. So that's basically the Federal Information Processing Standard for cryptography. So this is a level 2 certified. So if you are in a situation where you're required to use FIPS level 2 certification or compliance, then I think you need to consider KMS. Or if you require level 3, that's where you have to look at more hardware-based encryptions. So very similar to other resources within AWS, CMK is also controlled by policies. So those are two policies. One is the resource policy. The other one is identity policy. So primarily, who can access, who can do what with the key depends upon the combination of what you define within these two policies. When you create a key, a default key policy is applied where no one will have access to the CMK. Only the root account of the account that actually created the key will have full access to it. No one else will have access to it. We have to create custom policies if we want to enable other access as well as cross-region access. I'll show that in a minute and how those policy looks like. And finally, deletion. So we cannot delete these keys instantly. We can only schedule deletion. So that's anywhere between 7 to 30 days. And once we have deleted the CMKs, we cannot decrypt any data that was previously encrypted with those CMKs. Since most of these are automated, done by in the background, what I will do is I'll just simulate a few steps of the KMS operation just to see how those keys looks like. This is my personal AWS account, and I'm in the Oregon region. So I've got an EC2 instance running in. So I have already SSH into the instance. So what we're going to do is, so if you look at, for example, the KMS. So if you look at AWS Managed Keys, I haven't got any because I have not used any AWS services for encryption. So if I've used, for example, S3 or CloudTrail or any other services, then I might have now keys listed in here, starting with AWS. So that's an indication that's an AWS Managed Key. And if I've created any custom keys, then it would get listed in here. So for the session today, we're going to create a custom key. So that should appear here shortly. So basically what we are doing is we are mimicking what KMS would do when it is requested to create a CMK and subsequently encryption keys. So the command is AWS KMS create key. Region is be using Oregon, right? So that must be US West. So KMS, so these are the commands. So basically KMS create is the CLI command to create the key. And we're just giving a description that it's a demo key. And we are also mentioning the region because KMS keys are region specific, as I mentioned before.
Region is US 2, US West 2, I think.
Oh, so West 2, okay. Okay, I made a small typo as well. Okay, so when we run this command, it creates the KMS CMK, and this is the key ID. So as I mentioned before, it's the numerical reference to the CMK, which is normally quite difficult to remember. So that's why normally we have something called as alias. Let's see if it gets reflected here. Okay, so as you can see, the CMK is now showing up on our KMS console. So this is the key we just created. So this is the CMK. So the next step is to basically create a friendly name for it. So we can create something called alias. So KWS, KMS. Target key ID. So this is the target key ID. So we are asking KMS to create an alias for this KMS. So just copy paste that. I will send these commands in a separate material, so something for you to refer back. In the region, correct? Okay. So we are asking KMS to create an alias for this key ID, and this is the alias name, and this is the region. So if we come back to the console, so this is probably much easier to refer. So if you are creating custom keys, these alias will come quite handy if you are using it through APIs and other ways of accessing them. Next is the key step. So this is where the actual data key is generated. So this would give us two things. So one is the plain text version of the key, and the second is the ciphertext, which is the encrypted version of the key. So let's create. AWS KMS, to generate the data key, we're given the key ID alias, which is the demo key 0804, which we created here, and using the AES 256, and the region is US West 2, right? Sorry, I keep making this mistake. Okay. So basically what this has done is it has created the data key from the CMK, sorry, for the CMK. So it has this 2 bits of information. The first is the plain text key. So this is what is usually used to encrypt and decrypt. And the second one is the ciphertext blob. So this is the encrypted version of this key. Using the encryption algorithm we have requested here. So what normally happens is, for example, if we look at our previous scenario, where there is a file created by a user stored in S3, they wanted encryption. So then the request would have come to KMS, it would have created a CMK, and then it would have created a data key like this, which would have had both plain text and the ciphertext. And then it would pass these 2 pieces of information back to S3. And S3 then would use this to perform the encryption, and then it discards this key. It will end up saving this key along with the data for data at rest. And once it required to be decrypted, then S3 picks up this key, pass it back to KMS saying, I know I need decryption for this. And then KMS perform this operation again, generates the plain text key again, pass it back to S3. So S3 can use this to decrypt the file, then which can be opened for access for the user. Any questions so far? Normally, you don't have to do this because this is done as part of KMS Automated Key Management Service. So this is just to give an idea of how these keys are generated, how a plain text looks like, how a ciphertext looks like. So if we go back to the key that we have generated, so this is the policy I was talking about. So this is the resource policy. It's on JSON. So if you look at it, it allows the principal, so basically the root user, all operations on KMS. So that's basically the default policy, and you can customize them depending on your requirement. And also you can combine them with the identity access policy to do a variety of things, suiting your situations. Key rotation. So this is a custom created key. So this gets automatically rotated every year. And when it comes to deletion of this key, let's try and see if we can delete this key. We cannot delete this key, as you can see. We can only schedule key deletion. So by default, it's 30 days. If I try to reduce, say, 0, so it can be deleted today, I can't. It gives me error saying waiting period between 7 to 30 days. So once I schedule it, it becomes a soft delete material, and after 7 days, it gets deleted. So let me schedule one and see what happens. So let's schedule for 7 days. So the status changes to pending deletion. So it doesn't get deleted yet, but we can go ahead and cancel the key deletion if you want, if you think it's a mistake.
So if a key gets deleted, let's say take 30 days and the file is still around, is there any way to recover that?
No, unfortunately, no. That's gone. So that's why key deletion should be really, really a last resort unless there is a real requirement to do so. And again, these things are not going to take too much space, and these are stored securely in KMS anyway. So it's useful to have them around rather delete.
Okay, so there's no other way like master key or something at Amazon that they can do anything?
No, usually not, because the CMK that you have generated is generated by you, right? So if it gets deleted, it's deleted. That's it.
Okay.
So the actual source CMK itself can be restored, but again, you have to request AWS for that, but it might not necessarily decrypt the other keys that below that. So the master key for your KMS can be restored if you delete it. For example, if you mess with this policy, you see the policy that you see here, right? So for example, if you accidentally delete this policy, edit something, mistakenly you deleted the whole bit, accidentally saved it. That's it, your key is gone, right? But in that situation, AWS can restore that for you.
Okay. Is there any source control kind of things, like people, if they by mistake they've deleted it, they can go back in a history or something?
As far as I'm aware, no, it's not available in here, but I'll certainly check if there is any other means to see a history or log of all keys that's been deleted or managed. I'll certainly check for that. Okay. But I haven't seen one before, no.
Okay. Would that be case in all the cloud providers, or it's just Amazon specific?
This is more Amazon specific. I've just started doing things on Azure, so I'm not sure how it's done on other service providers. But I would assume it's going to be very similar.
Yeah.
Because the point of cloud is to simplify administrative activities as much as possible. So key management is a complex activity. So I would like to think they would adopt a similar. In many ways, most of the service providers simply copy AWS, just give a different name to it. So I would assume it's going to be the same in many ways.
Okay. Yeah.
Cool. So I know it's a slightly dry concept. The good news is AWS does most of this work that we mentioned here for us. It's just for our beneficiary to understand what goes on behind the screen operation. Also, if you're looking for certifications and stuff, knowledge of KMS and how it works really helps. particularly in security-based scenarios. Mhm.
Is this the same sort of events that would be repeated? So whatever events that you just charted out for creating the DEKs to encrypt and then decrypt, is this the same? This is the same stuff that would happen when KMS is used in conjunction with other AWS components like Kinesis or Redshift or Lambda.
There are minor tweaks, but largely the concept is same. So you have a service that needs encryption so that it would contact KMS, and KMS would generate the required keys and manage them for the service. And when there is a need to encrypt or decrypt, at that point in time, KMS can actually provide the actual key to do so. So that's in effect is the principle. So that takes away the headache of maintaining the keys at service level. So you have a central key management system to which you can refer to that does all these things for you. And it has a detailed registry database that goes back years where you don't have to particularly refer to specific keys. KMS knows, it maintains a registry. So it exactly knows what key we are talking about, and it does everything for us in the background.
So in terms of scalability, so would it scale to what the sources? So if you are adding new sources for ingestion, would it scale to those? So today, let's say we have got 4 IoTs, but tomorrow, if we've got 5 more IoTs or 6 more IoTs added, would it be scalable enough to encrypt those data from those IoTs as well, or do we need to do any manual intervention here?
So KMS is a managed service, so scalability comes with it. I haven't seen anything specifically within KMS to configure scalability to our need, but based on my usage and my understanding, the scalability comes, with it. So it really depends on your usage. It automatically scales up and down.
The reason that I ask is that in certain services, I think Amazon restricts for a cost or a size ratio. So it says for this size of, you can say you can read or write, as you said, 1 KB. You have to pay X amount of US dollars for doing that operation. So is there any sort of restriction on cost?
I mean, the limits of the service.
Yeah.
I don't recall any, but while we are here, let's do a quick Google, see. So you can have maximum 10,000 CMKs, alias is 10,000 as well. Correct. So it does have limitations. And I think once you breach those limits, you have to contact AWS customer support to help them. So the resource quotas is something that's where the key is creation part side of things. And the request is where you access them and use them as part of your API and other things. So yes, it does seem to have some limitations, but these can be lifted when you speak to customer service, depending upon your scenario.
Cool, right. Yeah, cheers. Thank you.
Thanks for bringing it.
Yeah.